Welcome to another video on friction. Another video on friction. Now, what is friction? I'm going to give you some things. You have to be very patient with this aspect. I'm going to deal with the word aspect of friction and at the same time the calculation aspect of the friction. Number 1 point on friction. Now we have friction to also be known as frictional force. You should know that. Friction can also be known as the frictional force. Now, friction is divine. It is divine as a force that resists an object's motion. An object motion on a surface. Friction is defined as a force that resists an object motion on a surface. Number 3, you should know that friction opposes motion. Friction opposes motion. Number 4, friction is also known as contact force because it's always work in contact, because it takes place between two surfaces. It takes place between two surfaces. So if those surfaces are not in contact, friction will not take place. So that's why we can call it contact force. So friction, it depends on two surfaces. Take note, friction depends on two surfaces. Number 5, frictional force is a resisting force. Is a resisting force which acts at surfaces, of separation, such as surfaces of separation of two bodies in contact. Frictional force is a resistive force which acts at surfaces of what? Of separation of two bodies in contact. Now this is number 5. Number 6, frictional force is non-conservative. Frictional force is non-conservative. Now what do I mean by non-conservative? It means that the work done in the moving object depends on the part it takes. When it's not conservative, that is, it cannot be conserved. That's what they mean. That's what it means. When an object moves from one position to another against friction, the energy is not conserved. As some of it is lost through it, because friction produces heat. That's another one. So friction produces heat. These are the things you have to know about the friction. Now, let's talk about another aspect of the friction. Now, we talk about the types of the friction. Types of friction. Now, what are the types of friction that we have? Now, the types of friction that we have, number 1, we have the static friction. Number 2, we have the kinetic friction, or we can call it dynamic friction. Number 3, we have the fluid friction. And don't forget, this kinetic friction or dynamic friction can be divided into two. We have the first one. We have the sliding friction. The sliding friction, or we have the rolling friction. Sliding friction or the rolling friction. Sorry, it should be a single D. Sliding is single. Now, what do we mean by the, we can say it, sliding friction or the rolling friction? Now let's talk about this one after the other. What is static friction? Static friction. If you are talking about the static friction, we can say the static friction is the limiting frictional force. Limiting frictional force. Now let's talk about some things under the static friction. This force arises when object is stationary. Is stationary relative to the surface. When the force arises, or this is the force that arises when the object is stationary relative to the what? To the surface. This is what we know as a static friction. In short, when both surfaces are at rest, when they are at rest, then we can say it is static friction. Even the static friction, when you are trying to push an object from a surface, you are trying to push an object from a surface, but the object is not moving, it's still making use of the static friction. Mind you, for static friction, the object remains stationary, that is, it remains at rest. Number two, this force happens when the body is just about to move over another surface. So when the body has not moved, then it's still making use of the static friction. But once you push an object, or once the object starts moving, it's no more static friction, then it's called kinetic friction, or we call it dynamic friction. Number three, always note that the static friction increases with the applied force. So, as you are trying to apply the force on the object, let me say you place a box on an horizontal wall. You are trying to push it. Now that's the applied force. You are trying to pull or you are trying to push. Now when you are trying to push the box or you are trying to pull, then that's the applied force. The static friction now increases with the applied force until it reaches a maximum value. Until it reaches a maximum value, and you should know, once it reaches this maximum value, or let me even count it as part of it. Once the applied force reaches maximum value, then the object starts to move. it starts to move. And once it starts to move, then that shows that it's being converted to what? To the kinetic friction. Take note. So once the applied force you applied on the box, you are trying to push it or you are trying to pull it, it reaches the maximum value of it. That is, it reaches the maximum effort you can apply. Then it makes the what? The box to what? To move. Then that means the applied force overcome the what? The frictional force. That the static friction, the static frictional force. But once the applied force has not been able to overcome the static frictional force, then the object will not move. But once the applied force overcome the static frictional force, then it will what? It will start moving. That is all about what? About the static friction. Now the another one is the kinetic friction. Another one is kinetic friction, or call it dynamic friction. Now this one, this force arises when objects moves relative to the surface. The same thing applicable to what? Same thing applicable to the static friction. This one arises when object is at what? Is at rest or stationary. But this one arises when object moves relative to the surface after the applied force. After the applied force overcomes the static friction. You know, if the force you applied has not overcome the static friction, then the object will remain what? Will remain at rest. Let me give you an instance. Now, if you have a box like this, and you try to push this, you try to push it like this. When you try to push this, if it is still at stationary, that is, it's still at rest, it does not move, then we call it static friction. But once you push it and it tries to move, it's changed. Let's say, let me give you another diagram. You have this box, you try to push it and it shifts the position. Once it shifts the position, that is, it moves, then we'll call it what? Kinetic friction. Kinetic friction. But we now have two types of kinetic friction. You know, I told you, it depends on the parts at which it moves with. Now, number two, under the kinetic friction, if objects slides, take note, if object slides over another surface, it is called sliding friction. If the object slides over another surface, it is called sliding friction. Don't forget, that is why I said the kinetic friction is divided into sliding friction and rolling friction. Now, another one is if object rolls over another surface, it is called rolling friction. It is called rolling friction. It is called rolling friction. Now please take note. Now, next one. But before we move, take note this, that if you can know this, you are good to go. And what is the note? You should note that static friction, the first note, coming. You should note that the static friction is greater than the kinetic friction. Number two. And don't forget that kinetic friction can be sliding or rolling. So the sliding friction is greater than the what? The rolling friction. That is under the kinetic. Don't forget, kinetic divided into this. Now, in short, altogether, that shows that the static friction is greater than sliding friction, in which the sliding friction is greater than what? The rolling friction. I should take notes. So don't forget, the two are found in what? In the kinetic friction. That's the next aspect. Next aspect, we talk about the advantages of friction and disadvantages. So friction can serve as foe, which is enemy, or as what? As friend. Friction can serve as foe or as what? As friend. Now let's talk about the first one. As foe, which is enemy. Or we talk about its disadvantages. What is the disadvantages of friction? Number one, it causes wear and tear in objects. It causes wear and tear in objects, especially machine. You see, when you start machine, when you have it, the efficiency of the machine will keep decreasing. And if you see very well, those parts that normally undergo friction, like those parts of the machine that undergo friction, will definitely decrease in the value as time goes on. Number two, it causes damage of some parts of the machine. So I said it, the first point as well. Number three, it reduces the velocity of the moving object and causes it to stop. Now, if you want to experience this very well, if you get to the mechanical engineering students, or you get to the mechanical engineers and you tell them to help you to increase the brake of a machine or the brake of a car, it's not allowed the car to move freely. The car will not be able to move freely. So that is it. So number four, it requires extra energy. It requires extra energy to push and pull. It requires extra energy to push and pull. Number five, it generates unnecessary heat. It generates unnecessary heat. Example, if you are talking about the brake of a car, when you start applying over time, it will generate what? It will generate heat. So it generates heat due to what? Due to friction. These are the disadvantages of what? Of friction. Now let's talk about as friend. As friend, that's what? These are the advantages of friction. Number one, it allows motion on a surface possible. It allows motion on the surface to be possible. Now, for instance, if you want to run on a surface, that's why you do not slide. That's why you are able to run on a surface on the ground because of the what? Because of the two surface in contact allows what? Friction. To drive as well, that's why they make the surface of the tire to be coarse, so it can never be smooth, because to allow the friction. And ability to write on the book as well, even to write on the board, to write on the book that I'm using now, they cannot make the surface of this book now to be smooth. If it's very smooth enough, it has to be coarse. So if it's smooth and shining, I will not be able to write on this. You can try it on nylon. It's not be able to write. Now you can have, and at the same time, ability for you to working, etc. So that is the advantage of what? Of friction. It allows us to grab and catch things. I believe you can understand this. So it's make us to grab something easily, or to what? To catch it easily. Next one. It prevents slipping. Prevents slipping and sliding. So it's not allow us to slide. Now when you place a ladder, that's why you can easily see a ladder placed on the wall. The two surfaces are in contact and not smooth. So they must allow what? They must allow the what? The friction. So it's the friction allow them to stay. That's why we can be able to use what? Ladder. And at the same time, when you place an object on top of each other, it is possible because of what? Because of friction. The two objects can stay on each other because there's a friction. Now if you place an object, very big object with shiny surface, with like maybe nylon on another one, you observe that the top one can come down because it does not have what? Does not have what? Friction. Now another one, it keeps hand warm. It keeps hand warm in winter when rubbed against each other. It keeps hand warm when rubbed against each other. At the same time, it allows vehicles to stop using brake. It allows vehicles to stop using brake. So whenever you use brake, it's possible because of the friction. Now these are the advantages and disadvantages of what? Of friction. Now the next one, let's talk about the laws of friction. Now the first one, the laws of friction. The first one says the frictional force is proportional to the normal reaction. We call it normal reaction, or you say normal force. The frictional force is proportional to the normal reaction or normal force or normal load. That is Fr is equals to the coefficient of friction multiplied by this. Or some people use R, so it can be Fr is equals to this. So but in this case, I'll be using normal reaction to be N. I'll be using N for normal reaction. Number 2. The frictional force is independent of the area in contact. Of the area in contact. The frictional force is independent of the area in contact. Now what do you mean by this? Or of the area in contact between the surfaces. Between the surfaces. Now you all know that the pressure is equal to force over area. Now this shows that as the pressure increases, the area what decreases. Yeah. You all believe with me that if you have this surface, you have this surface, and you have this surface. If you check this very well, these three particles, they cover different area. Now since they cover different area, let's assume that they have the same weight, but different area they cover, but they have the same weight. Now if I want to push this, if I want to push or if I want to pull it, you will observe that, you can practicalize this, you observe that the same force at which I use on each of these will be similar because they have the same weight, the same weight. So that shows that the area at which they cover is not matter. as far as friction is what is concerned. So that's why we say that the frictional force is independent of the what, of the area in what, in contact. Assuming they are what, they are placed on the floor like this, you will still use the same similar force to push this. Number three, frictional force depends on the nature of the surfaces. It depends on the nature of surfaces in contact. Now, yes, it matters. You will believe with me that the rough surface will have high friction than the smooth surface. At the same time, the static friction will have high friction, or it will be greater than what? The kinetic friction, as I said. Number 4. Kinetic friction is independent of the velocity of the moving object. That is, the speed does not change the amount of the what? Of the friction. That's why, irrespective of the speed I use here, you can still, it will still be what? The same force at which you are going to use. But irrespective of the speed, it does not change the what? The value of the what? Of the friction. Now that is all on the what? On the laws of what? Of friction. This is all on the laws of friction. Now the next aspect we'll be looking at. Now let us take a look at two cases of friction. We are talking about the cases of friction. I'll be talking about the number 1 here. Number 1 here. And what's the first one? The first one is when you have an horizontal surface. We talk about the horizontal plane. Now, the horizontal plane when you have the horizontal plane and you have a box, you place a box on the horizontal plane like this, you all know that it will definitely have what? The mass. Now, there will be an effect of this surface on this box, and that effect that we have on this box is what we know as what? Is what we know as normal. That is the force of the normal reaction. So the N is called normal reaction. It's called normal reaction. Don't forget, I told you that N can also be equal to what? R. That is, you can use N or use R. In some textbooks they use R, some places they use N. Anyhow, now this box will have an effect on the surface, and the effect at which it's going to have on the surface is what is known as W. Now W is known as weight. Is known as the weight. Now, in this aspect of the horizontal plane, take note, W is equals to, or let me even say, the normal reaction is equals to W. Normal reaction is equals to W. And this your W is equals to mg. That shows that if I say that normal reaction is equals to W and W is equals to mg, that shows that the W is equals to mg and normal reaction can also be equals to what? Mg. In this case of horizontal plane. And at the same time, let's assume that you push, you know, you can push or you pull. You applied a force on this surface. When you apply the force on the surface, let's assume that you apply the force here. You apply the force, the applied force, let's say F. You apply the force, so F is applied force. You apply the force to this side. it is either you push or you what, or you pull. So when you pull like this, the frictional force will opposite the what, the motion of this applied force. So the frictional force will be in opposite to this one. So that is why. So Fr is what? Is frictional force. Is frictional force. But take note, under this aspect, don't forget, under this horizontal plane, I told you that normal reaction is equal to what? The weight. And at the same time, the frictional force is equal to what? Is equal to the applied force. At this aspect, the frictional force is equal to what? The applied force. And don't forget, I told you that we have what is known as, according to the formula, we have the frictional force to be equal to the coefficient of friction multiplied by n. So this is known as coefficient of what? Of friction. The coefficient of friction. Now, if this is coefficient of friction, don't forget the G we have here. The G we have here is acceleration due to gravity. Acceleration due to gravity, and it is constant. It is 9.8 meter per second square. But if you are given, sometimes you can be given to be 10 meter per second square, but it's 9.8 meter per second square. Now, if you have this formula to be this, if you are talking about the static friction here, you can have it to be the frictional force of the static friction can be equal to coefficient of the static friction multiplied by normal. And if it is for kinetic friction as well, for kinetic friction, you can have the frictional force of the kinetic friction to be equal to the coefficient of the kinetic friction multiplied by normal. So this formula holds. And at the same time, if you have this formula holds, you believe with me that you have the I can have the summation of the force here. Summation of the force to be equal to the applied force minus the frictional force. Take note. Summation of the force can be equal to applied force minus what? Minus the frictional force. And what is your summation of the force? Summation of the force, don't forget that force is equal to what? MA. And if force is equal to MA, you can have it to be F minus the frictional force formula is coefficient of friction multiplied by what? N. Now, if you observe this very well, our N is equal to what? Mg. N is equal to what? Mg. So once M is equal to Mg, we can say that Ma is equal to F minus the coefficient of friction multiplied by what? Mg. Now with this, I can say A is equal to F minus coefficient of friction Mg, or better still, you can leave it like this. You can just leave it like this. But for the sake of those that they can ask you to find the what, you should find the what, the A, you should make A the subject formula. So if you want to make A the subject formula, but it's better you leave it like this. So if you know this, you are good to go. So you are good to go with the what? With the horizontal component. Now, case 2. Case 2. If you are talking about the inclined plane, now for the inclined plane, let us look at this. If you have something like this is an inclined plane. You have the box on this. This is the theta here. Now there's a theta here. Look up. This is a resolution. This is how we resolve the inclined plane. Now, you have, instead of your normal reaction, you know, this is how the box is facing. So the box will have the normal reaction on the words. The surface. The surface will have the normal reaction on the words. On the box that is here. Now, the weight will be directed like this. Now, if the weight is directed like this, we have to resolve this weight. these weights can be resolved vertically like this and horizontally like this. Now this weight that is resolved like this, we have this side that belongs to the theta here. This side that is at the side of the theta to be W cos theta. So the other side here will be W sin theta. So the side that does not have, the side that belongs to the side of the theta will take cos. But the side that is not at the side of the theta will take what? Will take sine. And don't forget that shows that it is the what? It is this W sin theta that is moving this box forward. And at the same time, the frictional force will be opposite the what? The motion of this force. And take note, whenever you have an applied force, use P. So use P as the applied force. Use P as the what? As the applied force. Though I don't include P here, it depends on the structure of the question. Let me take a look at this place. Assuming they said the applied force that can push the object up, then that shows that the applied force P will against the box like this, because it must try to push the box up. And assuming they said the applied force to make the box slide. So if it's to make the box slide, then that shows that it is P in order to push the box downwards. So whenever they talk about the applied force, but this is the original structure of the what? Of the inclined plane. I'm going to use this to resolve the inclined plane. But whenever they talk about the applied force, add P to it. Now, what are we going to use about this? Let's see the resolution. You will observe that the end here is directly proportional, like the same thing with this W cos theta. That means under this inclined plane, our end is equal to W cos theta. They are direct. And at the same time, our frictional force Fr is the same thing with what? With W sin theta. Now, if N is W cos theta and Fr is W sin theta, we have a theta here. This theta is known as angle of inclination. Angle of inclination. That is the theta here. This W cos theta, this W sin theta rather, is called the parallel force. The parallel force, or we say the force down the what? Down the plane. This W cos theta, this W sin theta is parallel force. The Fr here is also parallel force. It's also parallel force, but it's frictional force. Don't forget, it is frictional force. But it's what? It's up the plane. It's up the plane. So if you can see, the direction is towards the up of the what? Of the plane. But take note, whenever you are dealing with this friction, even sometimes if they tell you that the box is pushed up, if the box is trying to be pushed up, don't forget that the frictional force will not be facing up again. The frictional force will be facing down. Yes, when we get to the question, you know what I'm talking about. Because always know that the frictional force opposes the what? The motion. And at the same time, now, don't forget that you have what you know as the frictional force to be equal to the coefficient of friction multiplied by N. The coefficient of friction can be Fr over what? Over N. And what's your Fr? Fr is W sin theta over N is W cos theta. Now that shows that I can say W cancel W. So the coefficient of friction can be equal to sin theta over cos theta. And at the same time, this is equal to what? Tan theta. So the coefficient of frictional force can be equal to what? Can be equal to tan theta. Because on the norms, when you are dealing with trigonometry, well, when you are dealing with angle rather, sin theta, yes, when you are dealing with trigonometry angle, sin theta over cos theta is equal to what? Is equal to tan theta. You have to take note very well. You have to take note very well. Now, and at the same time, you have this W cos theta here, this W cos theta is known as perpendicular force. Perpendicular force is known as perpendicular force. The normal reaction N is normal reaction or what? Or normal force. Normal reaction or normal force. Now, next one is that, don't forget, as I resolved the other one the other time, I told you that. Now, don't forget that we said that Fr is equals to the mu multiplied by what? N. I can say that Fr is equals to the coefficient of friction, and what's our N here? Our N here is W cos theta. I can have Fr to be W cos theta. Therefore, the frictional force of the static can be coefficient of static friction W cos theta. And the frictional force for the kinetic can also be the coefficient of the kinetic friction W cos theta. You should take note. Now, as I did for this one, now I said the summation of the force here is F here minus the frictional force here. The same thing applicable to this. The summation of the force here is equals to the one you have here, which is W sin theta, the minus the what? Minus the frictional force that you have here. And with this, you have your summation of F to be MA. To be equals to W sin theta minus what's your FR? Our FR here is the coefficient of the frictional force W cos theta, and MA is equals to what's our W? W is weight, which is equals to what? Mg. So W is weight, which is equals to Mg. So we have Mg sin theta minus coefficient of friction Mg cos theta. Now you can just leave this like this. Now I only help you to break it down in case they ask you to find what? The acceleration, and this is how to do it. Now you can even factorize the common out of these two. So MA, and because what is common here is Mg, then what will remain here is sin theta, the minus the coefficient of friction cos theta. So this holds, but you must try it to what? To understand the concept. Now let us apply all this on the what? On the question. Let us apply all this on the question, because in physics, whenever you are given the formula, you have to apply so that you know if you truly understand or not. And the first question, a wooden solution, a wooden mass of block like this. They said it rests, this one is 1.6 kg. Said it rests on a rough horizontal surface. Rough, that is, there is a friction. This one we have the normal reaction N, so have the weight W, and W is Mg, and our mass is 1.6 multiplied by this. Said we should take our G to be 10, so it becomes what? 16 Newton. And don't forget that N is equal to weight, so N is also 16 Newton. They said if the limiting frictional force between the block and the surface is 8 Newton, now let's say it's applied the force here, and the force is 8 Newton. Don't forget, I told that the frictional force here will also be what? The normal the applied force. Yeah. So that means the applied force, the frictional force, is also what? 8 Newton. We're asked to calculate the what? The coefficient of what? Of the friction. And the frictional force is equal to coefficient of friction multiplied by normal reaction. Coefficient of friction will now be frictional force over normal reaction. Frictional force is 8 Newton over the normal reaction is 16 Newton. So the answer is 0.5. 0.5. Don't forget, the frictional force does not have any units. Does not have any units. That's the question. Number 2. See, the question says a force of 20 Newton is required to get a box. That means to get a box of 4 kg. This box is 4 kg. Let's say this is applied force and it is 20 Newton. Then they said the applied force is 20 Newton. Required to get this box. The normal reaction N is here, but we have the weight of this to be what? To be mg, and that's the m here is 4 times, let's say we use what? Let's say we use 9.8 here as our g. Let's take our g as 9.8 meters per second square. Now what is 4 multiplied by 9.8? That's 39.2. We have it to be 39.2 Newton. So that shows that since our weight is 39.2 Newton, then N is equal to W as well, which is 39.2 Newton. And at the same time, we are asked to find the coefficient. So the frictional force will be coefficient of friction multiplied by N. Coefficient of friction will be frictional force over N. So the frictional force here, don't forget, will be the frictional force as well, will also be the same thing with the applied force, which is 20 Newton. So you have 20 over the coefficient of friction, over normal reaction. And normal reaction is 39.2. The answer will now be, that's 20 divided by 39.2. The answer is 0.5. So we have this to be 0.51. 0.51. That's the answer. If an object just begins to slide on a surface inclined at, now the theta is 30 degrees. They said it just begins to slide. We are asked to find the coefficient. Now the best thing you can use here is the coefficient is equal to what? Tan theta. So the coefficient will now be tan 30 degrees. So the coefficient will be, what's tan 30? We have tan 30. That's 0.58. 0.58. Yeah. The last question for today says a block of mass 4 kg is released from the rest. So that means it's going like this. The direction is like this because it's released from the rest. So this is 4 kg. The normal reaction will be here. This will be the weight. Set at an angle 30 degrees. And don't forget that this one, if you resolve these weights, this will be W cos theta, which is, and this side as well will be W sin theta. Don't forget the resolution. Now say, since it's coming like this, then that means the frictional force is like this. Now said, what with the horizontal, what's the acceleration down the plane? Acceleration down the plane. So we are just asked, and this is the only down the plane. That is, or this is down the plane. This up the plane. Acceleration down the plane. So if you are asked to find the force is equal to MA. So an FR here will be equal to, FR will be W sin theta. FR will be W sin theta as well. But if you are using F to be equal to MA, A will now be F over what? Over M. So A will now be, since our F, our force, our frictional force is equal to what? Is equal to W sin theta. So we now have it to be W sin theta all over. That shows that we are using the frictional force to be equal to what? To be equal to MA. So when we have the frictional force to be equal to MA like this, then our M, you have your A to be, what's your W? W is the mg, so sin theta over M. M here we cancel M. So A will now be G sin theta. So A will now be what? Let's take our G to be 9.8. So 9.8 sin, we have the angle to be 30. So A will now be, so that's 9.8 sin 30. 9.8 sin 30. Sorry, there's a syntax error. The answer is 4.9 meter per watt per second square. So we use this as a force because it is the force down the plane that we need. Because the question is, what is acceleration down the plane? So because it is acceleration down the plane, that's why we use the force down the plane, and our force equals to what? MA. Now, if you want more questions, because this is just the beginning of the questions on frictional force. Now, there are a lot of questions. There are some tough questions. I still have like 15 questions more to solve. but it's not be contained on this episode so that the video will not be too long. So it will be contained on the next episode, so of this frictional force. So please, as you just watch this, check the channel for the second part of the frictional force. But that one we only deal with questions. So that means I'm starting from the question number 5, in which I stopped here. So that will contain some gigantic questions that many people normally fear under the frictional force. So let us just quench it with this simple method of the analysis. Thank you very much. I remain Ishola Blessing, popularly known as General David. So you can reach us on the WhatsApp on 070-6377-6455. Thank you. God bless. Like, comment, and share for other people to use. Thank you.